What is an SSD and how does it work? You know when someone says, just by swapping the HDD for an SSD my computer was reborn? It's not an exaggeration. Today, in 2025, practically every new notebook already comes with an SSD, and many people upgrade only this part and see the PC booting in seconds instead of minutes. So let's do this. In the next few minutes I'll show you, step by step, what an SSD is, how it works inside, and which type makes more sense for you whether you study, work or play. What is an SSD in one sentence? Let's get straight to the point. An SSD is a storage device, just like an HDD, where the system, programs, games and files are installed. The difference is that the SSD has no mechanical parts, everything is electronic, using flash memory, the same idea as a thumb drive, but much faster and more reliable. If the HDD is like a record player, with a spinning platter and a needle searching for the music, the SSD is like a supercharged flash drive, data is on chips, and access is almost instant. How the SSD stores your files inside. Inside, an SSD is basically a controller, a brain that organizes everything. Several flash memory chips where the data is actually stored. When you install a program or save a file, the controller breaks that information into small pieces and distributes them across the chips. When opening it, it knows exactly where each piece is and reassembles everything in milliseconds. And the important detail: it doesn't need to spin anything or move any needle like an HDD. That's why access time is much lower and the PC responds faster to everything you do. Why the SSD is so much faster than the HDD? Imagine two situations. With an HDD, it's like searching for a book in a huge shelf, walking back and forth. With an SSD, it's like typing the book's name into a system and having it appear in your hand. Technically, the SSD has much lower access time. More read/write operations per second. No mechanical parts to get in the way or slow down the process. In practice, this becomes Windows opening in a few seconds. Programs and games loading much faster. A more fluid system, without constant small freezes. Just one important detail: an SSD does not increase FPS in games. It doesn't perform miracles on the GPU. What it does is reduce loading times, making map changes, screens and startup much faster. Types of SSD: SATA, M.2 and NVMe. Here comes a classic question: which type of SSD should I buy? Today, the most common are SATA SSD, 2.5. It's that rectangular one, similar to a notebook HDD. Connects with a SATA cable. Advantages: compatible with most older PCs and notebooks, more affordable. M.2 SATA SSD. Physically it's a thin stick-like board that fits into a slot on the motherboard, but internally it works like a SATA SSD. Advantages: more compact, no cables. M.2 NVMe SSD. Also a small board, but uses the NVMe protocol via PCIe, which allows much higher speeds. In practice, it's the type used in many modern notebooks and gaming PCs, ideal for those who want even faster load times. One thing that confuses people: M.2 is the physical format. SATA or NVMe is the communication technology. Meaning, M.2 can be SATA or NVMe, depending on the model and motherboard support. SSD versus HDD, which to choose today? Today, the cost-benefit of SSDs is much better than a few years ago. Prices have dropped, and it has become the main choice for operating systems and programs. Quick summary: only SSD, no HDD. Great for those who want a light, fast notebook with less noise and don't need to store tons of files. SSD plus HDD together. Very common in gaming PCs and for those who work with many large files. SSD for Windows and programs, large HDD only to store videos, photos, old projects, backups. Only HDD. Today it only makes sense for cheap, large quantity storage, like 4 terabytes or more, when speed isn't that important. Do SSDs wear out? Lifespan and care. Another very common question: do SSDs have an expiration date? They do, but with one detail: for common use, they usually last many years. Flash memory has a limited number of write cycles, and manufacturers specify this in TBW, how many terabytes can be written over its lifespan. For an average user who browses, studies, plays and works normally, it's very hard to reach this limit before replacing the machine. Basic care. Don't keep the SSD at 100% full all the time. Keep some free space for the system to work well. Avoid running sketchy optimization programs that force unnecessary rewrites. The good news is that, because it has no mechanical parts, the SSD is more resistant to drops and vibration than an HDD. Great for notebooks that are always being carried around. How much SSD makes sense for you? Instead of memorizing crazy numbers, think like this. Use the PC for studying, browsing, basic stuff? 240 to 500 gigabytes of SSD usually works well. Play a lot and install heavy games? Then 1 terabyte of SSD starts to make more sense. Work with video, audio, design, or huge files? It's common to use 1 terabyte or more of SSD for current projects and a large HDD to store what you're not using. When it's worth combining SSD and HDD. This combination is very popular because it brings together the best of both worlds. SSD, speed for the system, programs and games you use the most. HDD, cheap space to store everything that doesn't need to open quickly. A practical example. Install the operating system and your main programs on the SSD. Leave old video folders, backups, and files you rarely open on an internal or external HDD. This way you feel the PC fast day to day, without spending too much on high-capacity storage. Closing, what do you do now? So, to summarize in a simple image. HDD is a huge cabinet, but a bit slow to open and move things around. SSD is a smaller cabinet, super organized, with everything at hand and very fast access. Today, if you want your computer to wake up quickly, open programs without suffering, and load games with less waiting, having an SSD is no longer a luxury, it's basically mandatory. Now tell me. Do you already have an SSD or are you still only on HDD? And if you're upgrading or buying a new one, which type are you thinking of getting, SATA, M.2 or NVMe? Comment below and I can record a video just helping you choose model and capacity.